There's still a holy grail that scientists are searching for, and it's called a theory of everything. What is a theory of everything? Well, this is general relativity and quantum field theory. Both are good descriptions of the universe, but they don't match up, which is weird because they both describe the same universe. Or, if you put them together, you get a message from the universe to physicists trying to understand it. God recommends you quit fucking trying. General relativity is the brainchild of Einstein, the king of science himself, and more or less says that gravity is a geometric property of space and time, meaning space and time can also be distorted. For more information, see black holes, high speeds, and pop brownies. Quantum field theory, on the other hand, describes the very little world of the subatomic and says that particles are what you get when you excite fields. Humans like describing complex phenomena with models. We did it with economics and computer science and the British political system. The dream is to finally do it in physics with relativity and quantum mechanics and get them to take their clothes off together and get their freak on. This would revolutionize science. However, there are some serious compatibility issues and lots of the problems come from the Standard Model. Last week we touched on the Standard Model, which is a pretty nifty description of how matter works, but there is still some outstanding homework to be done by humanity. Firstly, symmetry. Normally nature is a pretty classy girl, but in this case she's gone all loosey-goosey. Almost everything in nature is symmetrical when we look deeply enough into her, or it, rather. This can be seen from honeycombs, to galaxies, to the first very good seasons of Dexter, to the other ones. However, physics is currently not very symmetrical, and we don't know why. Problem 2. Dark matter. The universe is behaving a bit oddly at the moment, and while it seems overweight when it gets on the scales, we can't seem to find all that extra mass anywhere. This is where dark matter comes in, which is an invisible mystery ingredient that the Standard Model currently can't explain. Thirdly, gravity. We all know it exists, especially my ex-girlfriend. But the Standard Model currently takes the approach of la gravitons maybe don't want to talk about it. Oh look, a kestrel. What we need is a theory of everything that explains gravity and dark matter and reunites relativity with quantum mechanics and does a little backflip for a cheeky encore. Here are some delicious theory of everything recipes that scientists have tried so far. Recipe 1. String theory cake. To bake a string theory cake, you will need several kilograms of scientific optimism, a jar of hidden spatial dimensions, and a sprinkle of supersymmetry. The basic idea is this. Just like the strings of a violin can play lots of different notes, particles may be made of common objects called strings. If they vibrate at different frequencies, they create different particles. One of them may even be a graviton, finally explaining what gravity actually is. However, string theory wasn't happy with the usual missionary position of 3 dimensions of space and 1 dimension of time that we're used to. No, in some versions, she needs 26 dimensions to make the maths work. Anything else we can get for you, string theory? Cup of tea? Massage? Fucking private jet, you insufferable diva? Recipe number 2, loop quantum gravity cake. Combine a little self-raising flour with the tears of Michio Kaku, and voila! Loop quantum gravity is string theory's slightly more awkward but still very clever main competitor. If gravity really is a property of space-time, like some scientists believe it is, instead, space might be made of loops, forming something called a spin foam. And even though it doesn't explain everything yet, it does kind of explain gravity, so, you know, that's alright, isn't it? Recipe 3, miscellaneous. There are plenty of other theories of everything, such as causal dynamical triangulation, which divides space-time into dinky little triangles and solves a number of problems that way, or modified Newtonian dynamics, which tries to explain dark matter away by sitting Isaac Newton down and giving him a stern talking to, or the E8 model, which is a very pretty geometric explanation for how all particles interact with each other. And finally, recipe number 4, shut up, no cake for you, also known as Gödel's incompleteness theorem. Mathematician Kurt Gödel decided to give everyone the finger in 1931 by pointing out that no system of mathematics is self-contained. Or, to put it another way, if you have any arithmetic in a system, there will be things you can never ever prove for certain. That might mean, according to Gödel, that we can never have a true theory of everything. So, thanks for that. Dick. Anyway, these are all fun ideas, but maybe none of them are correct, and the real answer will turn up unexpectedly one day, with very little warning, at a totally inappropriate moment without our permission. Much like a certain Windows update, Microsoft, you bunch of total cunt.